Hi guys, this is Ms. Goal. Welcome to the first lesson in Module 2, Opposite Quantities Combine to Make Zero. Your outcomes for today's lesson are students add positive integers by counting up and negative integers by counting down. Students play the integer game to combine integers, justifying that an integer plus its opposite add to 0. And students know the opposite of a number is called the additive inverse because the sum of these two numbers is 0. The first thing we want to do is gather what we know about the number line. So I have provided a number line here below. And what we're going to do is we're going to organize what we know about a number line using a Venn diagram. So if you haven't seen these before, this here is an example of a blank Venn diagram. And over here we have this circle representing negative numbers and this circle over here representing positive numbers. So the area out here represents the elements that pertain only to negative numbers. Likewise over here, the numbers over here or the statements over here pertain only to positive numbers. And then this area here where they cross over is things that apply to both negative and positive numbers. So let's start there because one of the most obvious things that we know about negative and positive numbers is that they exist on the number line. If we take a look at positive numbers, let's talk about some things that we know about positive numbers. Looking at the number line here, we can see that positive numbers always lie to the right of 0. One other thing I notice is as we move further to the right, these numbers are getting larger and larger. So we stated that these numbers get larger as you move right, but there's different ways that people may say this to indicate the numbers getting larger as you move to the right. So this can also mean gaining. It can mean an increase. And a specific example could be above sea level. One of the things you'll notice with these positive numbers versus the negative numbers over here is that the positive numbers don't typically have a sign. Once in a while you will see a plus sign in front of that number to indicate that it's positive, but we just assume in general that if you just have a number by itself that it is in fact positive, so it doesn't typically have a sign. And the last thing I want to note here is that positives each have an opposite number that is negative. So you'll notice here the opposite of -2 is +2. So these are simply the opposite of negatives. Now with those in mind, let's take a look at the negative numbers. So let's kind of follow along what we've done here. We know that positive numbers are to the right of 0 on a number line. Negative numbers are going to be to the left of 0. We noted that positive numbers get larger as you move to the right. You'll notice here that as we move to the left, these numbers are actually getting smaller and smaller and smaller. Now this is actually a very common misconception that we need to fix right away. As you move to the left, they're going to get smaller. So that means that -10 is a smaller number than -8 or -7. Thinking about real world meanings of negative numbers, they can mean a loss. They can indicate a drop. Instead of an increase, the negatives would indicate a decrease. And going along with our real world example, it would indicate below sea level. Now all of these examples all have a sign on them, so they always will have a negative sign. And just to give some examples of our negative numbers here, we have -7, and just because you don't see it here in the number line doesn't mean it doesn't exist. You can have decimals and fractions as well. So we could have -3/4, and we could have -5.2. Notice all of these have that negative sign in them. Okay, let's take a look at example 2, counting up and counting down on the number line. It says use the number line below to practice counting up and counting down. Now these are new terms to us, so we need to define what does counting on mean. Counting on basically means counting by ones on the number line. Counting up on the number line is going to correspond to moving towards the positive numbers. So this corresponds to positive numbers. And the opposite of that would be counting down corresponds to negative numbers. So if we take a look at part A, part A says, where do you begin when locating a number on the number line? So let's say, for example, I wanted to show the value of 7 on a number line. I'm always going to begin every number at 0. So that would answer our question here. Where do you begin? You always start at 0. So let's say we want to first show how do we represent 7 on a number line. And there's a couple ways to do this. The first way is using basically just a straight line to show the distance from 0 to 7. Another way to do it is called the hop method. This is where you're going to start at 0 and you literally hop from number to number. So 2, 3, 4, 5, 6, 7. Both of these are going to represent a value of 7. Now let's actually show the opposite of 7 is going to be negative 7. So with our straight line method, we would just move above it and go down 7. So this is representing negative 7. With the hop method, you're still going to hop. 2, 3, 4, 5, 6, 7. And so this is also going to indicate a negative 7. The one that I prefer is actually the straight line method. You can use whatever method you like. You will just see me always doing a straight line method rather than a hop method. So what do you call the distance between a number and 0 on a number line? This is actually something that you would have learned in elementary school. This is called the absolute value. The distance between 0 and a number is the absolute value. And just a refresher, the notation that you're going to use for absolute value would be straight lines, vertical lines around a number. So let's just say any number would be x. A specific example might be the absolute value of negative 7. So you can just see it's straight lines on either side of the number. What is the relationship between 7 and negative 7? Well, let's take a look back at our number line. If you actually notice, if we took this line of 7 and moved it down and matched it up here, you'd see that they're actually the same length. And the reason for that is they're the same distance from 0. So therefore, they have the same absolute value. Okay, let's take a look at example 3 using the integer game and the number line. Now the integer game I'm going to explain to you tomorrow, and basically it's a card game that you will get to play in a group. So in this case, I have 4 cards in my hand, and what they're asking me to do is to find the value of the sum of the cards shown. And we're going to do this using a number line. So this is a skill that you're going to need for class tomorrow. So as I stated before, when we're starting with a number, we're going to start at 0. So the first number I have in my hand is 5. So I'm going to start with my dot. I'm going to draw a straight line to 5. So that represents a value of 5. The next card I have in my hand is a negative 5. Now here's the only difference is that because we're trying to find a total here, we're going to start at the very end of our first line. And then the next time we'll start at the end of the line we did previously. So here I'm going to go above 5, do a dot to indicate the beginning of my line here. Now this is a value of negative 5, so I need to go towards the negatives 5 units. So if I go back 5 units, I actually end up back at 0. So this represents our negative 5. Their next card is a negative 4, so I'm going to start just above our last arrow. And since it's a negative, I'm going to continue heading towards the negatives 4 units. Here's our negative 4. And the last card I have in my hand, it has a value of 8. So I'm going to go above the arrow on the 4. and I need to move back 8 units. So I know that if I go from -4 to 0, that has a value of 4, and I'm going to continue on 4 more for a total value of 8. And what you can see here is this brings us to a final position of 4. Part B says, what card or combination of cards would you need to get back to 0? You'll notice that 2 of the cards we had were opposites, and they brought us back to 0. So we had a +5, and then a -5 brought us back to 0. So if I'm at 4, I would want a -4 to bring me back. But notice the question says, what card or combination of cards? And this is something you're going to want to think about when you're playing the integer game tomorrow. You could have a combination that still gives you the value of -4. So for example, if I had a -1 and a -3, when you add those two together, they're going to give you a total value of -4, so you still get the same results. So basically what we've been talking about here and showing on the number line is opposites. So for all numbers A, there is a number -A such that when you add them together, they're going to have a value of 0. This is called an additive inverse, and we're going to highlight this. This is really important vocabulary. The additive inverse of a real number is the opposite of that number on the real number line. For example, the opposite of -3 is 3. A number and its additive inverse will always have a sum of 0, and the sum of any numbers and its opposite is equal to 0. In this lesson, you have learned to add positive integers by counting up and add negative integers by counting down. An integer plus its opposite always have a value of 0. The opposite of a number is called the additive inverse because the two numbers' sum is 0.